Since today's lesson is on proportions, let's start with some key ideas. A proportion is an equation stating that two ratios are equivalent, and two quantities that form a proportion are proportional. So let's determine if some ratios are proportional. Our first example, we're determining whether 6 over 4 and 8 over 12 form a proportion, if those two ratios are proportional. We're going to do that by comparing the ratios in simplest form. So 6 over 4 will reduce to simplest form, which is 3 over 2. And then we'll do the same thing for 8 over 12. In simplest form is 2 over 3. So we can tell by comparing these two ratios that they are not proportional. Let's look at another example where we have a ratio table. Here we have several ratios of x and y, and we're going to compare each of those ratios in simplest form to see if they are proportional. So our first value of x is 1/2, and our first value of y is 3. So we have a complex fraction 1/2 over 3. We can simplify that to 1/2 times the reciprocal of 3, which is 1/3, and that's 1/6. So we just did 1/2 divided by 3 and got 1/6. Our second ratio is already in simplest form, 1 over 6. We don't need to simplify that one at all. Our next ratio is 3 over 2 all over 9. So that's 3/2 divided by 9, or 3/2 times 1/9. We can simplify here before we multiply. And again, we get 1/6. So this is looking pretty good here. We have one last ratio to compare. That's 2 over 12. And that's also, it simplifies to 1/6. So all of these ratios are proportional. Okay, let's take a look at one more key idea. And that's the cross products property. In the proportion A over B equals C over D, the products that are diagonal from each other, A and D and C and B, A times D and C times B, are called cross products. So we're going to look at one last example, and we're going to determine whether two ratios are proportional using both simplest form of the ratios and also the cross products property. So for this example, we're looking at swimming, and you swim your first 4 laps. If you're not sure what a lap is back and forth, 2 lengths of the pool, and you swim your first lap in 2.4 minutes. You complete 16 laps in 12 minutes. We want to know if the number of laps is proportional to our time. In other words, are we swimming the same speed the entire time? So we're going to compare our unit rates, which is another way to say we're going to simplify the ratios. So we're going to start with 2.4 minutes over 4 laps. And then our other ratio is 12 minutes for 16 laps. And in both of these, we're going to reduce the ratio to figure out how long does it take for just 1 lap. So in our first ratio, we're dividing by 4. 4 divided by 4 is 1. 2.4 divided by 4 would be 0.6 minutes. Then in our second example, we're dividing by 16. 16 divided by 16 is 1. 12 divided by 16 would be 0.75 minutes. So is the number of laps proportional to your time? No, it's not. We must have slowed down a little bit after those first 4 laps. Now, we're going to look at the same example, but this time we're going to use the cross products property to also prove that our times are not proportional. So we're going to start with the same ratios. 2.4 minutes for 4 laps. And we're going to set this up as if it is a proportion. So I'm going to put an equal sign, but I'm going to put a question mark above that equal sign because we're not sure yet if these are proportional. We're going to check. So we're going to see if that's proportional to 12 minutes over 16 laps. Then we're going to use cross products to see if 2.4 times 16 is equal to 4 times 12. So 2.4 times 16, we want to know, is that equal to 4 times 12? So 4 times 12 is 48. 2.4 times 16 is 38.4. So at this point, we can see we don't need the question mark anymore. We can use a is not equal to symbol because 38.4 is not equal to 48. So we've proven in another way that these two ratios are not proportional. Okay, go ahead and try a few on your own, and I will see you soon.